welcome to the deep dive. Today we're looking at something pretty interesting, maybe even a bit surprising. It's about a weak spot in some really advanced AI. Specifically, how they struggle with, well, simple words like no or not.
That's right. We're talking about vision language models, VLMs. These are the AI systems designed to understand both images and text together. Linking what they see with descriptions.
Things like image search getting smarter or generating captions automatically.
Exactly. And this new study, it's from MIT, has basically found a fundamental problem with how these models handle negation.
So our mission today is to unpack that. What's the issue, and why should you listening care about it?
Okay, so the core finding from MIT is that these VLMs often just fail when they encounter negation. It sounds basic to us, right? Words that just flip the meaning. But for the AI, it's proving really tricky.
And that's not just a theoretical problem. It could have real-world consequences.
Absolutely. The researchers give this example. Think about AI in radiology, looking at an X-ray. Identifying, say, an enlarged heart is one thing. But correctly noting the absence of an enlarged heart is just as critical.
Ah, I see. So if the AI is biased towards only seeing what is there and kind of ignores the not enlarged part?
Precisely. You could end up with potentially wrong information informing a diagnosis. It misses the not.
Okay, that makes the stakes clear.
Yeah.
So how did the MIT team actually test this? How did they figure this out?
Well, they were clever about it. They built specific data sets, image data sets with captions that deliberately used negation. Things like a photo with no dogs or a picture where the person is not smiling. Simple, direct negations.
Okay. And then they tested the AI models against these.
Yeah, two main ways. One was image retrieval. Could the AI find the right picture based on a caption like no dogs? And the other was straightforward multiple choice questions, again, specifically testing the understanding of not.
Yeah. Let me guess, the results weren't stellar?
Not at all. For image retrieval, when the caption had negation, the accuracy just plummeted, dropped by nearly 25%.
Wow, that's significant.
It really is. And for the multiple choice questions about negation, the performance was barely above random guessing. Think like 39% accuracy.
Just guessing, basically.
Pretty much. And this pointed them towards what they're calling an affirmation bias.
Affirmation bias, meaning?
Meaning the models are just much, much better at processing what is present in the image or text. They latch on to the objects or concepts mentioned, even if they're negated.
So it hears no dogs, but focuses on dogs and gets confused.
Kind of, yeah. It struggles with the instruction to exclude something. It's like it can learn what a dog is, but not really grasp the concept of not a dog in a specific context.
Okay, so a pretty fundamental gap. Did they try to fix it, or at least improve it?
The first attempt was data augmentation. Basically, feed the models tons more examples.
Just show it more sentences with no and not.
Millions more, yeah. They added a huge number of new captions containing negation to the training data. The hope was, more exposure would help.
And did throwing data at the problem work?
It helped a bit. They saw maybe a 10% improvement in retrieving images based on negated descriptions.
Okay, 10%. Better than nothing, I suppose. What about the multiple choice questions?
That saw a bigger jump, actually, around 30% increase in accuracy there.
So some progress. But it doesn't sound like a complete fix.
Exactly. And the researchers are very clear about this. Kumail Alamud, one of the leads, basically said, we're simply augmenting data, not fundamentally changing how these models operate.
Right. It's patching the symptom, not curing the disease. Like you're practicing more, but your technique is still flawed.
That's a good way to put it. It's pattern matching on the new data, perhaps, not a deeper understanding.
Which, brings us back to those real-world applications. If the fundamental way they operate isn't changed.
Yeah. Mardea Gassemi, another author on the study, was quite direct. She said, and I'm quoting roughly here, if something as fundamental as negation is broken, we shouldn't be using large vision language models in many of the ways we are using them now without intensive evaluation.
That's a strong warning. Essentially, questioning deployment in high-stakes areas if they can't handle basic logic like not.
It really pushes for much more rigorous testing, looking beyond just, overall accuracy scores and digging into these specific linguistic capabilities.
So if just adding more data isn't the fundamental answer, what are the next steps? What are researchers thinking?
Well, they're exploring different architectural approaches. One idea is to maybe teach the models to process the image and the text more separately first.
Like understand the picture, understand the sentence, then try to combine them.
Sort of, yeah. Maybe handle the logical parts, like negation in the text, more explicitly before trying to map it to the visual information.
Interesting. Any other angles?
There's also a push for developing better, more targeted data sets. Not just more data, but data that reflects how negation is actually used in specific fields, like medicine or autonomous driving. Realistic scenarios.
Makes sense. Domain-specific testing.
Right.
So this MIT study really feels like a bit of a wake-up call then.
I think so. It highlights that even with these incredibly powerful models, we can't take understanding for granted. These nuances matter.
Then we should mention the researchers involved.
Yeah.
Kumail Alamud, Shaidan Al-Shamari, Younglong Tian, Guohao Li, Philip Tor, and Yoon Kim. Important work.
Definitely. And it's being presented soon at a major conference, CVPR.
Okay, so wrapping this up. The key takeaway seems to be, even super smart AI, these VLMs, can stumble on something as basic as no.
Right. It's not just a small quirk. It points to a potential gap in how they truly understand language, which needs serious attention, especially before we rely on them for critical tasks.
It underlines the need for caution, rigorous testing, and, well, more research.
Absolutely. And maybe a final thought for you listening. Think about all the places AI like this is starting to show up. If they can struggle with not, what other simple, seemingly obvious bits of human language might they be misinterpreting right now? What could the knock-on effects be? Something to consider.